What's up, guys? I'm Mr. Lanigan. This is Easy Mode Math. And for those of you in my class, we are jumping into Notebook 5 today, starting off the new 9 weeks with some new information. Now, we are going to be talking about measurement in this unit. And if you're tuning in on YouTube, thank you so much for watching. In this unit, in this video and in upcoming videos, we will be talking about area, irregular area, perimeter of triangles and quadrilaterals. We will learn real-world concepts like square footage, units of measure, applying these concepts in real-world situations as well. And then we will have a good time doing so. So let's jump right into it. This might be a little bit longer of a lesson, but we're going to break it down into the basics. Let's do measurement the easiest way possible. Easy mode. Let's go. So perimeter and area. Perimeter is the distance around the edge of a shape. It's like the outside if you were to go around it. Okay, whereas area is the amount of space inside a shape. And you can see here that we are talking about the inside based on these dotted lines and the outside based on these lines. Both of these concepts are extremely important. They are different, but they are kind of similar. We talk about them a lot together when we're learning them. And then lastly as well, they are used regularly in the real world. These are very relatable real world topics. So this is a great little picture of area and perimeter. The fence is going to be the perimeter and the grass is going to be the area. And I love that breakdown for these two topics. But we also want to talk about some examples from our lives for area and perimeter. Fencing off an area to plot a crop, or plant a crop, if you will. And that's, similar to what's in that picture. Planning the construction of a house, we would need area and perimeter. Building a barn with box stalls for the horses, great example. Planning out the wood for a construction project. And last but not least, building a swimming pool. Okay, there are other topics that we tend to include here later on, which would be volume and surface area, and we will get to those as well, but for today we're just going to limit ourselves to area and perimeter. So what I'd like you to do here is just pause the video and write down a couple examples for yourself of area and perimeter, whatever you can think of. See if you can think of 3 for each of those concepts. So go ahead and pause. Okay, so now that you have thought for a second and figured out some examples for yourself so you can connect to this, let's go ahead and move on. Let's take a look at the summary of the formulas that we tend to use for these topics, okay? But first of all, we want to go over some basic terms. Now, anytime we're referring to these letters, B, H, L, W, R, and S, this is what they're going to stand for: the base, the height, the length, the width, the radius, and the side. Now, this is probably something that you have seen before, unless this is a new topic to you, okay? In which case, these letters do tend to represent these words very often in mathematics. Now, the area is the measurement inside of a closed figure expressed in square units, and you can see that with apparently not my my information here, but the little 2, the exponent 2 on the inches would give us the square units. Now the perimeter is the distance around the outside of a closed figure, but we're going to have all this information in one place, and it's always helpful to go over it a second time. The circumference is just the perimeter when we're referring specifically to a circle. And then pi is the ratio of the circle's circumference to its diameter, and we know that to be typically used as 3.14. Okay, just some basic terminology to help you, some reminders, really. And we all need reminders. Okay, so let's take a look at the rectangle. The most basic area formula is length times width, and that comes from this rectangular shape right here as well. Now, the perimeter, we're going to get into this later, but the perimeter is the distance around the outside of the object, but we always have a formula for perimeter. And whichever way you want to calculate perimeter is going to be fine for you, whichever way makes the most sense. Now, your square has the same sides all the way around, so people tend to write this formula as s to the second power, but we can still do length times width. It's the same thing, the one side times the other side, okay? And then for our triangle would be 1/2 base times the height, because your triangle is going to be half of the square or rectangle in question, so it's really the same formula as the rectangle, just divided by 2. Next up, we have the circle, talking about pi and relating that to the radius, the circumference. There's the relating that to 2 pi times the radius. Okay, we may or may not spend as much time on circles as we do the other shapes, but today we're going to focus on the 4-sided shapes and the 3-sided shapes. So the trapezoid has the most interesting, complex, different, whatever you want to say, formula for calculating it, the area and perimeter. But basically you can see here the perimeter, you're just adding those 4 sides together, right? And that's the distance around that object. As for the formula, the 1/2 part is still there. The height is typically represented inside the shape, although not always. And then B1 and B2, those are the bases, or the lines. Typically, I guess I don't want to say on the top and bottom, because if we turn the shape, then it would be different. But you can see here the slanted lines; those are not used in the calculation for the area. And last but not least, we have parallelogram, which, is just basically a tilted square or rectangle with some diagonals in it, but we do the height and the base, and that ends up being basically the same as the length and the width. So you can see that these formulas end up being pretty similar. So let's go ahead and break down the formulas. Let's just try to pick up on some similarities. Look at how similar the rectangular and parallelogram formulas are. And we've already mentioned this, right? If when we're looking at this, it's basically the same as the length times the width in the parallelogram formula, but we need the distance from one side to the other, so we call that the height and use that in our calculation. And perimeter will always have a formula, but a shortcut here for perimeter is just to add all the sides together. And that's what I was talking about when I said you can calculate it however you want. If you like the formulas, then feel free to plug in. That will definitely get you the perimeter of the shape. But for me, I just like to add all 4 sides together, or however many sides are in my shape. Okay, so let's take a look at the first example for quadrilaterals, and we're going to take a look at a couple different ways to break this down here. Let me get myself situated. So if we take a look at a kind of like a breakdown of how area works, we would be looking at almost like little 1x1 squares that we can break down each shape into. Okay, so if we're looking at this second square here, then we have a 2x2 square, but it's broken down into 1x1 squares, 4 of them. And then the same thing with the other ones as well. It's broken down into these little shapes. So on this first one, that would be an area of 1 because it's a 1x1 square. Okay, now on this second one, there's going to be 4 of those squares, so that's going to be an area of 4. And we could get that by doing our same calculation of length times width. 2 times 2 is going to give us 4. And we are using those square units that we're going to be using every time we're talking about area as well. So then what would the area of this third square be? If you were saying 9 to yourself, then that is absolutely right. And then, of course, the last one would be 16. We're just increasing, the length and width, or, the side values by 1 each time. And we can find the perimeter for these shapes as well. Whereas on that first one, it would be 4 centimeters long. We're just using the normal measurements here. The square measurements are for area, and our normal measurements, just centimeters, would be for perimeter. Now on this second one, we would end up having a perimeter of 8, 2 for each side, which would make the third one 12 and the fourth one 16. Interesting that they have the same area. Okay, so let's go ahead and jump into our next set of examples here, where we're going to break down how to calculate the area and perimeter of these shapes. So if we take a look at our rectangle here, we're going to use this rectangle that's 11 by 4 inches, and our goal is going to be to find the area. Now, all we're going to do is multiply those two numbers together. You do need to be careful because sometimes they'll label all 4 sides, and then you need to pick out which ones you're going to be using, but the calculation is very simple. That would give us 44. Now, wait, be careful. You need to also put your label in here. Most teachers will take off points if you're not putting the correct labels, as that is a very important part of this topic. What about the perimeter though? So if we take a look at this, now our 2 sides that are the ones labeled here, this leads to some mistakes if we're not careful, because we need to add all 4 sides together, and that would end up giving us 30 inches. You can also use the formula in question, perimeter equals 2 times length plus width, but it's just as easy to add all 4 sides together. Either way you want to do it is perfectly fine and will result in the same answer. Let's scoot that 4 over. Let's jump into the second one with our parallelogram, and you'll notice that we have a height of 9 inches. Typically the height is labeled inside the shape, but not always. And then we have 2 sides labeled of 8 and 10 inches as well. So if I want to find the area, I'm going to go ahead and multiply the 8 and the 9. The 10 is not necessary for this problem because it's not the base or the height. That would give me an area of 72, remembering, of course, to put my label. What about the perimeter for this shape, though? Because that can be a little tricky since I have 3 numbers, but remember, it's the distance around the outside of the shape, so I'm actually going to add the 10 twice, the 8 twice, and that's going to give me a perimeter of 36 inches. Okay. On this last one, the trapezoid here, we have a height of 9, base 1 is 3, base 2 is 7, and the side length would be 12. In this diagram, it's assumed then that the other side length would also be 12, but we probably should have that labeled just so that's, clarified. For the area of this shape, we will be using that formula, and the 1/2 in the formula is always there. The 9 is the height, and then the 3 and the 7 would be your base 1 and base 2. All right. For this calculation, you want to add those 2 numbers together first, and then multiply the 3. That will give you a total of 45 inches squared. As for the perimeter, we want all of the outer edges, and in this, that would be 3, 12, 7, and 12 again, for a total perimeter of 34 inches. Okay, great. Let's clean it up a little bit, just so you can see on screen, with a little bit less messiness and our work. Our area for the first one, 40 inches squared, perimeter of 30. The second one, 72 inches squared, 32 inches. Third one, 45 inches squared, 38 inches, in case that was a little hard to see. All right, what about triangles though? Because those come up quite often. Let's go ahead and break down this formula as well. Notice that there is only one formula for triangles, but there can be many types. But they all use this formula, which is very cool. So we're going to have to be careful what numbers we're using for triangles, but we'll take a look at some common ones that come up though. Reminder, perimeter will always have a formula, but you can add the side lengths together too, same as the other shapes. All right, so examples of triangles. Let's take a look at this triangle here with a height of 10, two side lengths of 8, as well as another length of 6. We're going to find the area. And for this one, we're taking the 1/2, which is always in the formula, the height of 10, and the base of 6, and that would give us 30 inches squared. In order to find the perimeter, we're going to add up all three of the outer sides, the 8, the 8, and the 6, and that would give us 22 inches. But what if we have our triangle a little bit different? In this second example, this is going to be a right triangle, and in this triangle, we should have the right angle labeled, I would think. However, we do know that the 3 is the height, and that can be a tricky way that some problems try to get you. So for the area in this shape, we would be doing 1/2 times 3 times 8, and that's going to get us 12 inches squared. For the perimeter, we'll just add those three numbers together. I think this one's easier, but a lot of times this one tricks many people. That will give us a total perimeter of 23 inches. Let's clean that up again, and we'll have 30 inches squared for the area on the first one, 22 inches on the perimeter, 12 inches squared on the area, and 23 inches on the perimeter. To wrap up, area is a measure of how many units cover a surface, and we can break that down into little boxes like this if it's helpful. The vocabulary that goes with that is typically width or length. A practical application would be in acres. Perimeter is a measurement of the distance around a two-dimensional figure, and there we could be talking about the width, the circumference, the edges, etc. Just some additional information to wrap up here. So hopefully from this lesson, you will know what the concepts of area and perimeter represent, as well as the basics of how to find them. What questions do you have? Let me know in the comments section below. Send me a message. If there's any way I can help you, I will happily do so. For my students, make sure you get your other questions completed that go along with this and update your notebook. Thank you so much for watching. I'm Mr. Lanigan, and this has been another episode of Easy Mode Math, where we broke down area and perimeter. Have a great day.